Yeah, namaste everyone. So let's continue with the revision of this chapter, real numbers. Okay, let me share my screen. Okay, so we are going to discuss some word problems, okay, which can be asked in the board examination. Okay, so it says three bells toll at intervals of 9, 12, 15 minute respectively. If they start tolling together, after what time will the next toll together? Okay. See, toll means just like ring, okay? It is going to ring at interval of 9, 12, and 15. So we are having three bells, okay? So just to visualize, okay? We are having three bells. This is bell 1, this is bell 2, and this is bell 3, okay? I'll write B1, B2, and B3, okay? So there are three bells which are tolling at interval, that tolling means ringing at interval of 9, 12, and 15 minutes respectively. That means, for example, bell B1 is going to ring after every 9 minutes. Okay. So first it will ring after 9 minutes, then 18, then 27, and so on. Okay. It is going to ring in the multiples of 9 basically. Okay. Second one, multiples of 12, because it is going to ring at an interval of 12 minutes, every 12 minutes. So 12, 24, 36, and so on. Okay. Next 15, 45, 60, and so on. Okay. So we are having three bells, which is going to toll or ring at interval of 9, 12, and 15 minutes respectively. If they start tolling together, see now what we do now, we are going to start the bell at the same time. Like for example, 10 o'clock. Okay. See, suppose I have some switch or I have three people at who are standing, and as soon as I say ring, they actually, all the three bells, B1, B2, and B3, they're starting at the same time. Okay, we have three different people, maybe you can just assume, just visualize, we have three different people, and they're going to start the bell at the same time. Okay, so the question says if they start tolling together, that means all the three bells is going to ring together at the start. Okay. So for example, if you ring the bell at 10 o'clock, I'm just giving one example, 10 o'clock, the first bell will ring next at 10:09. Next, it will ring at 10:18. Next, 10:27. It'll ring like that. Okay. The second bell, 10:12, 10:24, 10:36. Third bell, 10:15, 10:30, 10:45, 10:60, like that. Okay. It'll ring like that, right? They're asking, if they start tolling together, that means if you make them ring at the same time, after what time will they next toll together? Okay. After what time will the next toll together? So when they will ring together again, at what time? Okay, maybe 11 o'clock or 11:30 or 11:45. At what time we have to find out? Okay. Now, because here they have not given time, so we'll answer with respect to minutes. After how many minutes they will toll together. Okay. Sometimes they will give time. We have questions we have done where we have done, okay, where they ask time, at what time they will ring together once again. Okay. So now, because it is a case of repetition, whenever we have a case of repetition, something is going to repeat, we always find the LCM. Please remember, whenever it is a case of repetition, something is repeating, we always find the LCM. Okay. So the three bells will toll together again at LCM of these three. Okay. The least common multiple of the three times which we are having will give you the time at which they will toll together again. Okay. I told you already that we have to find the LCM or HCF only using prime factorization. Okay. Only using prime factorization. Okay. So you have 9, 12, and 15. You write as a product of primes like this. 9, we can write 3 to the power 2. I'm writing in power form because it's easier. In the morning, I have already told you how to actually find the HCF and LCM using the prime factorization technique. Okay. So once you're able to express, you can find the LCM. What do we do in LCM? While you're taking LCM, we don't take common. Please remember, using the prime factorization technique, we don't take common. We see all the prime factors, each prime factor along with the highest power. So 2 highest power is 2, 3 highest power is 2, and 5 highest power is 1. Only these are the prime factors occurring. You multiply, you'll get 180. Okay, and it is going to come in minutes because time is given in minutes. Okay, so they will ring, the 3 bells will toll together again in 180 minutes. Okay, that means after 3 hours. Again, like for example, if the 3 bells toll together at 10 o'clock, okay, then it will toll again at 1 p.m. Okay, 1 p.m. again it will toll together. Okay, so after 180 minutes they will toll together. I hope it is clear. Just check. If you have a doubt, you can ask. Okay. Okay. Let's do this question. Okay. So 3 alarm clocks rings at interval of 4, 12, and 20 minutes respectively. Okay. So we are having, actually I've just given a picture so that you get clarity. Okay. Here I've actually written the multiples and explained. Okay. If they first ring at 6 a.m. together. Okay. So they're first ringing at 6 a.m. Together they're ringing. Like together they're actually ringing. At the same time, all the 3 alarm clocks are ringing. At what time will the next ring together? Okay. At what time will the next ring together? We have to find the time. Okay. So I'll take the alarm clock as ABC. I have given a name. So A alarm clock is going to ring at an interval of 4 minutes, right? So 4, 8, 12, 16, 20, 24, 28, 32, and so on, right? We can keep writing the multiples. I'm just writing few of them, correct? Next, B alarm clock. After every 12 minutes, it is going to ring. So 12, 24, 36, 48, 60, 72, 84, and so on, right? And same with the third alarm clock is going to ring at an interval of every 20 minutes. So 20, 40, 60, 80, 100, 120, and so on, right? Okay. Now, they are first ringing together at 6 a.m. They're asking what time will the next ring together. So if you look at their multiples, okay, one of the common multiple is 60. And that is actually the first common multiple, basically. Okay. And we have already learned what is least common multiple. In the morning batch, not in the morning batch, in the morning class, I have told you during the revision, I have told you that. Okay. Least common multiple, how do you find out? I've explained, right? With examples. So 60 is the least common multiple. Okay. That means after 60 minutes, again, they will toll together. Ring together. Actually, this will ring together. Okay. So after 60 minutes means after 1 hour, because 60 minutes is 1 hour, right? So if they first ring at 6 a.m., next it is going to ring at 7 a.m. Okay. Now, this is a technique I have actually used to explain the concept, but you should not write all these things in the exam. Okay. In the exam, you have to follow the prime factorization technique. Okay. Like this. Okay. You have to say like this. You have to write only like this. For this introduction, you have half a mark. Please remember in the board exam, no? For this introduction, you have half a mark. Okay. So 3 alarm clock will next ring together at LCM of 4, 12, 20. And then you find the LCM using the prime factorization. Okay. So we have found to be 60. So they will ring together again in 60 minutes. That is 7 o'clock. Okay. Okay. Next question. Similar type. 3 bells ring at intervals of 60. Okay. So it says 3 bells ring at interval of 60 seconds, 90 seconds, and 125 seconds respectively. See, once you understand a particular question, right, the approach, you can do any question. Okay. So it's a very similar one. So if they ring together at 1 p.m., then at what time will they ring together again? Okay. So the 3 bells will ring together like again at LCM of these 3. So whenever there's a case of a repetition, right, something is going to repeat. Okay, it's repeating, right? There, the bell is going to ring at an interval of 60, 90, 125 seconds respectively. We have three bells and it's going to repeat, right? So whenever there's a case of repetition, we find the LCM. That is the simplest technique. And for this only, they will give half a mark. For introduction, you have to write. For introduction itself, you get half a mark, okay? So you must understand when to find LCM and HCF, right? So whenever there is a case of repetition, you find the LCM. So you find the LCM using prime factorization. You will get this much seconds because all these are in seconds. So this is this much seconds. Okay. Now you want to find the time, right? They are ringing first at 1 p.m. When they will next ring, we have to find the time, right? Yes. So we'll convert this seconds into hours and minutes. Okay. Then it will be easy for us to find the time, right? So you know 60 seconds is 1 minute, correct? So 1 second is 1 by 60 of a minute. Okay. 4,500 seconds is 4,500 into 1 by 60. So it will get 75. And 75 minutes is 60 minutes plus 15 minutes. That is 1 hour 15 minutes. Okay. 1 hour and 15 minutes. 1 hour and 15 minutes. So if they ring first at 1 p.m., next they will ring at 2:15 p.m. Okay. So simple to understand. Check. I'll give one question. You try to do it. Okay. Based on similar thing. Just 1 minute. Okay. Try this. All of you try and put the answer. Dalan not right. See, Dalan, be very careful. Okay. Arush not right. Santosh right. I'll give you 2 more minutes and then I'll do this. Okay, let me do it. Okay, it says in a morning walk, 3-person step off together. Their steps measure 75 centimeter, 80 centimeter, and 90 centimeter respectively. Okay, see, you have to understand this question. We have done this kind of question in class also. Okay, a very similar one. Just the values have changed. Okay, so we have 3%. Let the 3% be A, B, and C. Okay, so in a morning walk, 3 persons step off together. So they're actually stepping out together. All the three of them, no, they're stepping out together. Okay. And the steps measure 75, 80, and 90. Okay. So when person A takes one step, no, one step, that is 75 centimeter. When person A takes one step, see, they're stepping off together. All of them are starting at the same time, basically. So when the person A takes the first step, it is going to measure how much? 75 centimeter. And next step will also be 75. Each step of person A is going to be 75, right? Because their steps measure 75. Okay. 80 for person B and 90 for, because respectively they have given, right? They are having 3 persons and their steps are going to measure this. So person A steps is 75 and next 75 and next 75. Okay. And so on. Okay. I'll stop here. Okay. So the step is going to be 75, 75, 75. It will go, keep going, right? Okay. Next. If you take person B, each step of person B is 80, right? So it will be somewhat more, right? It will be somewhat more, like maybe somewhere here. Okay. You can see it is just beyond this, right? So I've taken somewhat more, okay? And it'll keep going like this, right? So each step of person B is 80 centimeter, 80 centimeter, 80 centimeter. And person C, each step is how much? 19 centimeter. It'll be somewhat more, somewhere here. Okay. And then it'll keep going, right? This is 90, 90, and 90. Okay. They're saying what is the minimum distance each should walk? What is the minimum distance each should walk so that all can cover the same distance in complete steps? See, complete steps means if person A takes 75 centimeters in the first step, his every step will be the same. Okay. That is complete steps. Okay. If B, one step is 80, the next step will also be 80. Even the fourth step, even the fifth, every step will be 80, 80, 80. For C, every step, even if it is the 100th step, it will be 80 only. Sorry, 90 only. C, if you take C, it will be 90, 90, 90 like that. Okay. So it complete steps means it's not going to change. The distance is not going to decrease. The step distance is going to remain the same for all the three. For A, it will always remain 75. For B, it will always remain 80. For C, it will always remain 90. Okay. So what is the minimum distance each should walk so that they can cover the same distance? Now, they should walk for some distance in such a way that they cover the same distance. Okay. So suppose this is a start point. Suppose this is a start point and end point is somewhere else. Okay. We have put dotted lines, right? So dotted line means it is going to be somewhere else. We don't know where it is. So they should actually, we want to find out the minimum distance so that they can cover the same distance. For all the three will cover the same distance, but in complete steps. Okay. In complete steps. Okay. So how we can find that? We can find that by finding the least common multiple. Why? How do you know it is a case of a least common multiple? Because it is repeating, right? They are like each, like the steps are repeating, right? Yes or no? It's a case of a repetition. Yes. Since it's a case of a repetition, we find the LCM. Okay. Another way is, see, the first step is 75. Next step is also 75. So if you take the first step to be 75, just 1 minute. Okay. If you take the multiple, see, it's like taking multiple, right? See, if up to here, see, if you take up to here, it is actually 75. Okay. From here to here, it is 75 into 2, right? From here to here, it is 75 into 3, right? Yes or no? So it's multiple, right? Basically, it's a multiple, right? 75 into 1, 75 into 2, 70. Yes. So we are taking a multiple. So the least common multiple will give the answer. Okay. So we have tried just one line. The minimum distance E should work so that they can cover the same distance in complete step is LCM of 75, 80 and 90. We have to say like that. Okay. And then find the LCM. Then we have to find the LCM. Okay. So I'll do it. But the writing that introduction is mandatory. Otherwise, you lose some marks. Okay. So the minimum distance each should walk so that all can cover the same distance in complete steps is LCM of 75, 80 and 90. Okay. You have to write this line. Okay. Then you take 75 and look, it is not divisible by 2. So I have already told you in the morning that you have to actually go in order 2, 3, 5, 7, 11. Okay. We are doing prime factorization, right? So you take prime numbers and keep dividing. So 2, it is not possible. So next prime number is 3. It is divisible by 3. That is why I divided it. And then 5 5s are 5 1s. So 75 I can write as 3 to the power 1, 5 to the power 2. Okay. Then 80 is 240, 220, 210, 25, 51. So 80 is equal to 2 to the power 4 into 5 to the power 1. Okay. 90 is what? Okay. Then 3 1s are 3, 3 5s are 5 1s are 2 to the power 1 into 3 to the power 2 into 5 to the power 1. Okay. Now, LCM of 75, 80, and 90 is what? We don't take common in LCM. We have to take each of the prime factors of 2 and put the highest part. 3, 5. So if you do it, 2 to the power 4 is 2 into 2 into 2. Okay, 2 into 2 is a 4, 8, 16 into 9 into 25. Okay, so you multiply all of them, you will get 3,600. And you have to put the unit, it is centimeter. Okay. So 3,000 centimeter, and then you write one conclusion. Okay, the same thing you write, and at the end you write is 3,600 centimeter. Okay. So you have to write the conclusion as the minimum distance he should walk so that they can cover the same distance in complete step is 3,600 centimeter. Like that you have to write. Okay. Check. Check. Okay. Can you all try this question? Right, I'll come in a minute. It's not correct, Madesh. Okay. But not exactly that time. We have some seconds also left, I think so. Yes. You have to tell the exact timings, okay? Like even actually in minutes and seconds also will come. Actually, whatever you have answered, no, I'll tell you what is wrong with that. I'll tell you. I'll tell you. Okay. We will discuss. Okay, let's discuss. Okay. So listen, everyone. Everybody has answered 7 a.m. Anyway, let's understand. So the traffic light, Arush, and 20 seconds is not correct. Okay. Anyway, let's discuss. The traffic lights at three different road crossings change after every 48 seconds, 72 seconds, and 108 seconds, respectively. If they change simultaneously at the same time at 7 a.m., at what time will they change simultaneously again? So it is a case of repetition, right? It is changing the traffic light is going to change after every 48, after every 72, and then after 108 seconds, right? So it is a case of a repetition. So we have to find the LCM. So you have to write one line. I'm not going to write that line. Okay, you have to write one line that they will change simultaneously again at the LCM of 48, 72, and 108. You have to write those lines. I'll directly find the LCM of 48, 72, 108. 48 if you take. Okay, so 2 to the power 4 into 3 to the power 1. Okay. So 2 to the power 3 into 3 to the power 2. Then we have 108. So 2 to the power 2 into 3 to the power 3. So LCM of 48, 72, and 108 is 2 to the power 4 into 3 to the power 3. Okay. Because in LCM, we take all the prime factors and put the highest bar, right? So 2 to the power 4 is 2 into 2 into 2 into 2. 2 to the 4, 8, 16, and 9, 27. Okay, and if you multiply these two, 27 into 16, I'm getting 432. And what is 432? Seconds. Okay, that means after 432 seconds, they are going to ring again. But since time is given, we have to find the time again, like next what time they will ring. Okay, so we have to convert 432 seconds, okay, into minutes, okay, and like if it is possible, hours or minutes, okay. But this is actually small, so we'll try to convert to minutes. So you know that 60 seconds, I'll write S is 1 minute, right? So 1 second is how much minute? 1 by 60, correct? So 432 seconds will be how much minute? 432 into 1 by 60. Okay. So simplify. 2 3s are and 2 2s are 2 ones are 2 6 are. Okay. Next. Next, I can directly do with 3. Okay, I can do with 2 also, but I'll do with 3. See, 3 tens are 30. Look here. 3 7s are 21, 3 2s are 6. Okay. So I'm getting 72 by 10. Okay. I'm getting 72 by 10, right? Now, 72 by 10, this is minutes, right? This is minutes. And that is actually 7.2 minutes, basically. Correct? If you convert to decimals, it will be 7.2 minutes. Okay. Now, 72, 7, like, I mean, 72 by 10, I can write 7.2 minutes, right? So this I can write 7 plus 0.2 minutes, right? 7 plus 0.2 minutes I can write now. That means 7 minutes plus 0.20 minutes, right? Correct? Now, see, 0.20 minutes, if you want to convert to seconds, what do we do? See, 1 minute is 60 seconds, right? 1 minute is 60 seconds. So 0.20 minute will be how much second? 0.20, or if you want to just put 0.2, it's also fine. Okay, that is both is fine. Okay. So what do? We multiply, right? So 6 2s are 12. Okay. Put the 2 zeros because 1 0 here, 1 0 here, and put 2 decimal places because I have taken 0.2. Okay. So I'll get 12. That means 12 seconds. So 0.20 minute is 12 seconds. 0.20 minutes is how much? 12 seconds. Okay. So whatever answer I have got, 7.20 minutes is basically 7 minutes and 12 seconds. Okay. So the traffic lights will change simultaneously again. Okay. Like at 7 past 7 minutes, 12 seconds. Okay. So 7 o'clock it is going to first of all change. And then next 7 o'clock, 7 minutes, 12 seconds. Like that. Okay. So you have to write that. It will change again at 7, or maybe you can write after 7 minutes 12 seconds. Okay, or you can say 7 past 7 minutes 12 seconds, like that you can see. Okay, check. But this 7 minutes 12 seconds you have to write. It's not like 7 minutes 20 seconds. Okay, it's not 20 seconds. This is how you convert. I've showed the process also. 0.2 minute you multiply with 60 to get seconds. Okay, check. Okay, correct. We can write like that also. So we have done these questions. Okay, this is also a case of a repetition. Okay, so we find the LCM. This is actually from NCRT. Okay, so there's a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point at the same time and go in the same direction. After how many minutes will they meet again at the starting point? They will meet after 36 minutes. Okay. This question we have done right on a morning walk. The values may change, but the procedure remains the same. Okay. Next, we had seen these kind of questions. Okay. I mean, they ask check whether 4 to the power n can end with the base 0 for any natural number n. See, for this kind of questions, no, the answer is for answering, there's a standard format and you have to follow that. You cannot write your own theory. You have to follow this particular format. Now to explain this format, I have just used this concepts. Okay. See, suppose you have 10. 10 means 10 to the power 1. 10 means 10 to the power 1 also I can write, right? So 10 is nothing but 2 into 5. If you take 10, I can write 2 into 5, 2 power 1, 5 power 1, correct? If you take 100, 100 is 10 to the power 2. So 100 if you factorize, you'll get 2 to the power 2, 5 to the power 2, correct? If you take 1000, 2 to the power 3, 5 to the power 3. If you take 10 to the power n means any number, you'll get 2 to the power n, 5 to the power n. See, 10 to the power 3, you're getting 2 to the power 3, 5 to the power 3. 10 to the power 2, you're getting 2 to the power 2, 5 to the power 2. So 10 to the power n means you'll get 2 to the power n and 5 to the power n, right? So, whenever you are having 10 or multiples of 10, whenever you are having 10 or multiples of 10, 2 and 5, I'm saying 2 and 5, not or, 2 and 5 will definitely be a factor of the given number. Whenever you are having 10 or multiples of 10, 2 and 5 will definitely be a factor of the given number, always. See, these are factors, right? Basically, 2 and 5 are the factors of 100, and same with 2 and 5 are the factors of 1000. So whenever you have 10 or multiples of 10 means 100, 1000, 10,000, lakh, like that, okay? So whenever you have actually 10 or multiples of 10, you will definitely have 2 and 5 as a factor. Remember that, okay? Now, for example, you have 30. See, 30, I can write 3 into 10. That means 10 is there. Okay, in 30, 10 is there. Okay, suppose if I have 50. In 50 also 10 is there because I can write 5 into 10. So if a number is ending in 0, if a number is ending in 0, then also it will have 2 and 5 as a factor. You can see, whenever a number is ending in 0, it will definitely have 2 and 5 as a factor for sure. Okay. So remember that. Whenever a number is ending in 0, it is going to have 2 and 5. Both will be there. Not only 2, not only 5. Both 2 and 5 will definitely be a factor. Definitely be a factor. Okay. So if you remember these concepts, you can answer this kind of questions. Okay. So they're asking, check whether 4 to the power n can end with the digit 0 for any natural number n. See, 4 to the power n means what? If you take the number 4, I can write 2 into 2 to the power n. Yes or no? So 2 into 2 means 2 to the power 2. The whole power n. Yes or no? That means here the only factor is 2. 5 is not there. Okay. So for a number to end in 0, you should definitely have 5 also, right? I can rewrite this as 2 to the power 2n. How? Using laws of exponents, you can multiply these two. Using laws of exponents, you can multiply these two. You will get 2 to the power 2n. So it is only having 2 as a factor, right? And for a number to end in 0, it should have 2 and 5 as a factor. Correct? So we say if the number 4 to the power n for any n were to end with the digit 0, then it will be divisible by 5. Okay. See, if something is a factor, it will divide, right? Factors are the exact divisors. Today morning only we have seen that factors are the exact divisors. Exact divisors. We have seen that, right? So suppose if I have 10, 10 is 2 into 5, right? 2 is also able to divide 10, 5 is also able to divide 10. That is why both are factors. Okay. Factors are the exact divisors. So that is why this is written. So if a number 4 to the power n for any n were to end with the digit 0, then it would be divisible by 5. That is, the prime factorization of 4 to the power n would contain the prime number 5. So if you take 4 to the power n, if it is actually ending in 0, it should be divisible by 5. That means in the prime factorization of 4 to the power n, like 5 would definitely be there. 2 would also be there, but 5 would also be definitely there, okay? This is not possible because 4 to the power n means you can write like this only, right? Only 2 is there. So the only prime in the factorization of 4 to the power n is 2. See, 4 to the power n, only prime factor is 2, right? We don't have 8. And the uniqueness of fundamental theorem of arithmetic guarantees that there are no other primes in the factorization of 4 to the power n. So in the morning, like in the morning itself, we have learned the fundamental theorem of arithmetic, where we learned that every composite number can be expressed as a product of primes, and the prime factors are unique apart from the order in which they are written. Order can change, but the prime factors will not change. Okay, I have shown in the morning class that it will not change. Okay. So the uniqueness of fundamental theorem of arithmetic guarantees that there are no other primes in the prime factorization of 4 to the power n. So there is no natural number n for which n is the digit 0. Just go through this once. Give me 2 minutes. Just go through this. Let's just check whether you're able to understand. Okay. Just check the same way we have to actually write. Okay. You have to actually practice this, learn it. Okay. You have to write only in this sequence. Okay. But remember the concept for a number to end in 0, it should have 2 and 5. But here only 2 is there. 5 is not there. Okay. So we are writing like that. Okay. Same way, if you look at this question, same thing. Check whether 6 to the power n and can end with the digit 0 for a natural number n. So if you take 6 to the power n, 2 and 3 is there, 5 is not there. 6 is 2 into 3. So 5 is not there. 2 and 3 is there, but 5 is not there. But 2 and 5 should be there for a number to end in 0. Correct? So we'll answer the same way. If the number 6 to the power n for any n were to end with the digit 0, then it would be divisible by 5. That is the prime factorization of 6 to the power n would contain the prime number 5. This is not possible because 6 to the power n is, you can write 2 into 3 to the power n. That is 2 to the power n, 3 to the power n. All these things we write using laws of exponents. Okay, so the only primes in the factorization of 6 to the power n are 2 and 3. And the uniqueness of fundamental theorem of arithmetic guarantees that there are no other primes in the factorization of 6 to the power n. So there is no natural number n for which 6 to the power n and the digit 0. Okay. Same way here also. We have 2 and 3 alone. So we can answer accordingly. Okay. I have explained how this 2 to the power 2n has come by the laws of exponents. Okay. Next here. So this is a different one. I mean, here it is ending in 0, right? So check whether 20 to the power n can end with the digit 0 for any natural number n. Okay. So we'll say, see here it is ending in, it's going to end in 0 because 20 if you take, it will have both 2 and 5. If you take 20, 2 tens are 2 fives are 5 ones are 2 and 5 both are there, right? So here we'll write differently. So if the number 20 to the power n for any n were to end with the digit 0, then it would result by 5. That is prime factorization of 20 to the power n would contain the prime number 5. This is possible because 20 to the power n is 2 to the power 2 into 5 to the whole power n. So if you apply the laws of exponent, you will get something like this. So the primes in the factorization 20 to the power n are 2 and 5. So 20 to the power n always ends with digit 0 for any natural number n. Okay. You will not believe this kind of questions they're asking for 3 marks, sometimes 4 marks also. Okay. So please try to learn this. Okay. It's very easy. I've explained the basic concept behind answering all these questions. Okay. Same way here also. Prove that n to the power n and that is 0. Similar way we have to write. Okay. Now we have this proving kind of a thing. Okay, maybe I can discuss this in the next class. Okay, for this also we have a particular format which you have to follow. Okay. So with this, we'll stop. We'll continue the next class. Next class will be tomorrow morning. Okay. So regularly we'll have classes in the morning. Okay. And evening classes, okay, will be there as per schedule. Tuesday, Thursday, Saturday from 7 p.m. to 8 p.m. Okay. So I'll just repeat once again. Okay, quickly. So we are going to have classes in the morning. Today we started till 11th February. We'll have classes in the morning. Okay. Evening classes will be thrice a week. That is Tuesday, Thursday, Saturday from 7 p.m. to 8 p.m. Okay. So totally, if you see, we are going to have 52 hours of classes. Okay. So in that, we are going to revise all the chapters. We are going to see the basic concepts and solve some board questions. Okay. Next, in the month of March, since the board exam is on 10th, okay, so we are going to utilize all these days for writing the mock test, and we'll actually solve it during the class. Okay, the solutions we'll see during the class. Okay, so that is the plan. Okay, so with this we'll stop. Thank you so much everyone for joining in. Take care. Bye bye and have a great evening.
Thank you, sir.